So let's go ahead and draw in our axes here, just so we can kind of more easily get those points down. Some of you might not need to do this, but... Alright, there we go. And so let's plot here. So Q... Alright, so there's point Q. Ugh, and R is not going to fit. Well, isn't that just great? Alright. T is 3, 3. Okay. And we'll kind of connect the dots. Alright. So there's our shape. Alright. So our first step here, Mary, once we kind of graph this, what do you think we should do here to kind of kick things off? What should be our first kind of calculation, maybe? Okay, the slopes of all the sides? Yep, that sounds good to me. So slope of QR, that's pretty easy to calculate there. So let's see, the rise is 0, the run is 5, and the slope of TS also has a rise of 0 and a run of 5. Slope of TQ, run of 3 and a rise of 4. And the slope of RS, run of 3, rise of 4. Alright, so with that calculated there, Mary, what can we say?
It's a parallelogram because both the opposite sides are congruent.
Mm-hmm. Yep. Well, sorry, not congruent.
Wait, equal? Wait.
I mean, so the numbers are equal, but what are these numbers? Yes. So, because remember, we're not finding the distance here, right? Slope is not necessarily the same thing as distance. No, and that's okay. I mean, I know you know what you meant to say, but I just wanted to make sure, you know, for everyone else too, especially, you know, the people watching on YouTube right now. Just kidding. There's no one that watches these, but in case someone does, you know, yes, that's exactly right. The opposite sides, it's the slope numbers that are equal, and then make these sides parallel. Exactly right. So QRST is a parallelogram. Since QR is parallel to TS and TQ is parallel to RS. Okay? Okay. So that's good, but we still want to further prove it's a rhombus. Okay, we want to further prove it's a rhombus. So what makes a rhombus, or what can we do here, Drew, to kind of do that? That's right. That's probably the easiest way to go about this, right? Okay. Can anyone think of another way we can show that this is a rhombus besides checking the diagonals? We won't necessarily have to do it that way, but I mean, any other ways we could show it's a rhombus? What makes a rhombus a rhombus? Right. What's like the basic definition of a rhombus? It's a quadrilateral that is what? Mason? Yeah, equilateral. Exactly right. So Mason, how can we show that this is equilateral? What could we do?
Use the distance formula.
Yeah, and find the measure of all the sides. We're not going to do that, though. I think that's more work, because it's much easier to calculate slope than it is distance. Except the distance here isn't too bad, because we do have some nice horizontal lines there. But let's find the slopes. So, slope of QS, let's see here. From Q to S, I have to go down 4, right 2, so negative 4 over 2. And then the slope from T to R, let's see here, goodness, it's up 4, so rise of 4, And then run. Yep, 8. Okay. Alright, so we found those two slopes there, Drew, like you asked, or you said to do. Now what?
Since they're opposite reciprocals, they're perpendicular.
Okay, so I'm looking at these, and these don't look like opposite reciprocals to me just yet. What do I need to do still, though? Yeah, I need to simplify first, that's right. So make that -2 over 1, make that 1 over 2, and now, yes, exactly. Now I can very easily see -2 over 1 is opposite reciprocal. So we can go ahead and say QS is perpendicular to TR. Okay, and so therefore, okay, QRST is a rhombus. Okay. QRST is a rhombus. Yeah. Okay. So, can I get away with just like saying that? I mean, do I need to do this top part here, or can I just go ahead and say that? Can I just do the diagonals and say that QRST is a rhombus based off that? Do I need to say that it's a parallelogram first? Patrick, what do you say?
Couldn't you just get away with just saying it's a trapezoid? At least that is.
Oh, I see what you're saying. Like, so only show that one pair of opposite sides are parallel, and then do the diagonals, and then just that would be good enough.
Yeah.
I think yes, I think that would be sufficient. Yeah. Okay, I think that would be sufficient. Yeah. So I don't necessarily have to show the entire shapes of parallelogram. A trapezoid, I think, would be sufficient. So just showing one pair of sides are parallel, and then showing the diagonals are perpendicular. I think that would be sufficient there. But we definitely we can't just say, oh, because my diagonals are perpendicular, therefore this shape is going to be a rhombus. I mean, I can very easily kind of show you here an example, just if you will believe my sketch, right, of an idea. So let's say I'm going to make a shape up, and I'm going to draw it so that my shape has perpendicular diagonals. Okay, like that. Right? These diagonals are roughly perpendicular, and so then if they're diagonals, that means they're like endpoints of opposite sides, something like that. Okay? And this shape clearly, very clearly, does not have to be a rhombus. Okay? In fact, the way I drew this one, it looks kind of like a what? Yeah, a kite, right? But it doesn't even have to be a kite, right? I could draw something like this. Okay? Again, the diagonals are perpendicular, but if I connect those shapes, if I connect the vertices, or what would be the vertices there, okay, does not guarantee it has to be a rhombus. Okay, it doesn't guarantee that. So, keep that in mind. We do need to show that it's a parallelogram first. Okay, a rhombus is a parallelogram whose diagonals are perpendicular. That's like one way to kind of like make sure that it's a rhombus. All right? Questions on any of that? All right, let's flip it over then, and let's move on to number 13. And this one is wants us to prove that this quadrilateral we're going to look at here is a square. All right, so again, I'm going to kind of draw in my axes here because this is more helpful for getting those coordinates down right. Okay. I think my black pen is dying. We'll plot these points here. So A has coordinates 4, 1. B has coordinates 1, 5. C has coordinates -3, 2. And D has coordinates 0, -2. So connect those dots there. Okay. So really, first of all, does this shape look like a square? Yeah, it does, right? I mean, if you like turn your paper there, just kind of really convince, like, oh yeah, that looks like a square for sure. Okay. So to show this thing is a square, though, all right, what can we maybe start out doing here? So, oh goodness, let's go this one here. So Lindsay, what do you say? What should be our first step here to kind of start showing that this thing is a square? Yep, so again, we're going to start out the same way we always do. We're going to start out with a parallelogram. Make sure we got to show it's a parallelogram first. So, slope of AB, and AB slope is, let's see, I'll go from A to B here. So it's rise of 4 for me, run of -3. Of course, if you count the other direction, your slope will be a -4 on top, a +3 on the bottom, but those are still the same value, right? +4 over -3 is the same thing as -4 over +3. So it doesn't matter which direction you count, it should still be the same value. And then we'll do slope of BC. So that is down 3, left 4. Okay. Slope of CD. And then the slope of DA. All right. And so, Lindsay, from these slopes, what can we then say then?
You can say that side AB
Okay.
parallel to side DC,
Yeah, AB is parallel to DC.
and then side CB is parallel to DA.
CB is parallel to DA.
It's gonna be a telephone conference, you can take
Oh.
it during lunch.
Oh, okay, gotcha. So, like, I got to head in right now. Then, okay.
Well,
Yeah.
because she can take it from her lunchtime.
I gotcha. Yep, that's fine.
Isn't the D on the bottom CD?
Right here. CD.
No, on the slope. So the CD and then slope of DA.
DA. Whoop, there should be 3 +4 there. And then BC should be negative. There we go. I fixed it. So wait, I messed up a letter?
You're right. Never mind.
We're good?
You're right.
Okay, yeah, okay. Yeah, sorry. I did mess up my slope numbers though, so I did need to fix those. Yeah, that should be then 3 over 4. It's the same thing. So my mistake there on the slopes. I fixed the slope numbers now. Yeah, BC is either down 3, left 4, which would be a -3 over -4, or up 3, right 4, +3 over +4. And same thing with D.
I looked at it the wrong way. I looked at it going sideways instead of going up and down.
Okay, gotcha. And so therefore, whoops. So thus, ABCD is a parallelogram. Okay. And so real quick here, we'll show, let's see, AC, okay, the slope of AC. So now we want to show it's shoot, I'm jumping the gun here. Oh well, we'll go ahead and do this. So the slope of AC, now let's do that. The slope from A to C is up 1 and then left 1, 2, 3, 4, 5, 6, 7. So it's +1, -7. And then the slope of DB is up 7, right 1. And so with these two slopes, that means the diagonals then are going to be what here? Anybody? They're opposite reciprocals, meaning they are perpendicular. That's right. Okay? And so then, if that's true, ABCD is a what? A rhombus. That's right. Okay? And then one more thing we need to show. AB. Almost. We have to show before we can say it's a square. I need to also point out here, for example, that AB is perpendicular to what? CB, or you could say DA, either one there. Okay? And since these two sides are perpendicular and the shape's a parallelogram, what can we also say ABCD is? A rectangle. Okay, and yes, believe it or not, you have to do all this. And then since ABCD is both a rhombus and a rectangle, what kind of shape is both a rhombus and a rectangle? It's a square. That's right. Since it's both a rhombus and a rectangle, we can finally say it's a square. Okay? And so that's what's necessary to show that something's a square. You have to first show that all the sides, you have to first show it's a parallelogram, then that it's a rhombus and a rectangle, And then as a result of all those things, it must be then a square. Because only a square is both a rhombus and a rectangle. Okay?